Hello friends, welcome to Trich Institute, and in today's Pacemaker cluster on Suse Opensuse, we'll be discussing about SBD fencing. So how you can do fencing using SBD, that we'll be discussing. So before starting with that, let's have a discussion on the content we'll be covering here. Mainly we'll see what is SBD, then what is disk based SBD, and then how you can configure this one, and then what are the SBD timeouts and how you can manage SBD, and then we'll see also diskless SBD and that SBD start mode. So let's start with the overview. So SBD, from the first I'm telling you SBD, but what is SBD? So SBD is nothing but is the short form of STONITH Block Device. So there are two modes. One is your disk based SBD and another one is diskless SBD. So in the disk-based SBD, uh, it requires a shared disk. So from the name itself, we can understand it requires a disk, and that disk should be shared, and it must be available to all the nodes, and it can be a partition. But in a production, usually people don't use the partition; they use a separate disk for this. And the minimum size requirement is for x86 is 1 MB, and for power series it is 4 MB, and you should have one slot per node available. And this SBD daemon runs on every node, so it's not like on one node it will be running and other nodes it will not be. It should be running on all the cluster nodes, and this is like a systemd unit service, and you cannot start it or stop it manually, because if you see like a systemd, so you may think like, okay, I can run like systemctl start SBD or stop SBD. That it will not work. It can be started or stopped using a dependency from the corosync service, and it reads the SBD devices list from your the file etc sysconfig SBD. So now how you can configure this disk based SBD? There you have to, first thing you have to configure the watchdog, so that will be watching for the cluster health, node health actually. And then there are two methods to configure. One is your manually, where you manually create the SBD and attach it to the cluster and all, and then using the HA cluster init. That's like during the initial bootstrapping of your cluster, you can specify the SBD device. So these are the two methods you can do. So we'll discuss more about the manual method. So to manually configure SBD, first thing you need to do, you need to initiate a shared disk as SBD device. So if you see here, I have written as a shared disks. Why there is a plural form in that? Because if you keep only single SBD, that will be a single point of failure. So suggestions are always you should have at least three SBD devices coming from three different sources, so that you have uh, redundancy available for SBD also. So how you can initiate it? That command is SBD hyphen small d, then you put the device name and then create. So you can have multiple devices. So for multiple devices, you have to put like hyphen d, device 1, device 2, like that. You have to put it. And one thing here, there's a typo that SBD entire thing is in small letter. It should be not the S is capital. And you need to ensure that a hardware watchdog device is available. So usually most of the servers have this available, so you no need to think about that if you're using it on a physical server. If it is not available, then you use software watchdog. So there's a special use case for this, like if you are deploying your cluster on Azure, that's what I have seen there. So they don't have any hardware watchdog, so you use software watchdog. But before using that, you have to check it with Suse or that vendor, whoever is providing, so that it is supported or not, that you need to check from them. And you need to edit the main sysconfig files for SBD, that etc sysconfig SBD. Few parameters you need to edit. Main thing is SBD underscore device. There you need to mention all the SBD devices, like SBD device and semicolon SBD device 2 3, like that you have to write. And you have to put like SBD watchdog equals to yes, so you are using watchdog. And the start mode for SBD, whether you want to have it as a clean or always. We'll see it more details in the start mode in the later part of this presentation. We'll see that. And then to continue with this, you have once you're done with this, you have to propagate the changes to all the nodes. So that SBD configuration file you need to copy to all the nodes, and then you need to restart the cluster stack on all the nodes. So do this at the initial setup stage. Don't do it once your cluster is in production. Anyhow, without a STONITH device, configuring the cluster is not a supported method. So you have to do it during initial deployment phase. And then you have to create a cluster resource using external SBD primitive. So this command should looks like this: crm configure primitive stonith-sbd. So you're creating the SBD resource, stonith:\external slash SBD. And one thing to keep in mind here, don't specify the SBD device as part of resource definition. So this SBD service resource will be picking up the device from the SBD configuration file. And then you need to set the cluster properties like STONITH enable equals to true, so that cluster start using STONITH, and the STONITH timeout, that is default value is 30 second. Now we'll see more about the timeouts. So the correct timeout, why this is required? Because this correct timeout values ensure that correct operation of the SBD. So if you set it wrong or very large timeout, your cluster may not uh, act properly. So this is very important thing. So there are few timeout values, like one is message wait. So that timeout after which the cluster assumes that the message has been delivered to the other node. So it is usually longer than your iSCSI or MPIO error timeout. And for multipath, this should be your path failover time, and you have to use -4 option in SBD create command. And the watchdog, so that is one thing, read operation timeout for SBD device, use -1 option in SBD create, and it should be less than half of message wait. And the cluster property STONITH timeout must also be set. You have to set this to have a proper functioning SBD STONITH. So the formula for calculating this timeout message is equals to whatever your watchdog timeout value into 2, and whereas STONITH timeout value is message timeout plus 20%. So let's say your message timeout is around 100 seconds, so it should be like 120 seconds. But again, you have to test it in your cluster and see if it is responding properly as per your load and as per your architecture. Also, one thing to keep in mind, you can change this timeout value anytime using SBD command. So it's not like when you are deploying the cluster, then only you have to set it and it will be hard coded. It's not like that. You can change it any time. Now, as we have seen how you can create or configure a disk-based SBD and then timeouts and all, then how you can manage the SBD. So there's a SBD utility that you can use to manage it. So to show the SBD properties, if you want to see the SBD properties, that command will be like SBD-D, and you put the device name, let's say /dev/hdc, that's your SBD device, and then you put dump. So it will dump the properties of the SBD device. So to see the slot contents for that SBD, so that's nothing but in what all nodes this SBD is configured. So for that you use the command SBD-D, then you put the device name and then you put the list. So this is like an example. How you can find out the SBD device? Very easy. You grab SBD underscore device from etc sysconfig SBD, so that will list down all the SBD devices configured. So in this example you can see /dev/hda is configured as a SBD device, and then you do SBD-D on /dev HDA and dump. It will give you like header version, UID, number of slots it available, then sector size, timeout values for your watchdog, then message wait, all those things it will show. And then if you do list, it will show like how many cluster nodes are using that SBD device and what is the status for them, whether they're clean or not. So that it will show. Then to further continue on this, if you want to send a message to a device, that also is possible, that you can do using SBD-D, then device name, then message, which node you want to send that and what kind of message then you want to send. Let's say you want to send a test message, so you put test. If you want to reset the node, you use reset. If you want to power off the node, you use power off option. But keep in mind, if you are doing this during initial setup or during your some downtime maintenance window, then fine. Because if you do this reset or power off during a production time in an on business, I mean during a business hours, and if you do that, it will reboot the cluster node and can impact your applications are hosted on that cluster. Now, when you do that thing, so it put a message into your SBD from the node slot so that it will have a poison pill. Usually, this is common for fencing. When the node get fenced, so it gets a poison pill from on the SBD device. So that you have to clear to get it clean, because this is required if you are having SBD start mode set as clean. Because if it is not clean, your node will not be joining back to the cluster and SBD will not be getting started. So you have to clean it and then join it back to the cluster. Now we'll see the diskless SBD. Let's say you don't have a shared disk option, still you can configure SBD that you can do it without disk. So this is a self-fencing mechanism for a node. Usually you use it on a cluster with 3 or more nodes. So this diskless SBD cannot handle the split brain scenario for 2 node cluster. So you have to have a minimum 3 node cluster to use this. And for this most important thing, you should have a watchdog device. And if it is a hardware watchdog, that will be very much helpful, because sometimes software watchdog may not work. If your system is hang and all, it will not work. So in that case, hardware watchdog will be much more helpful. And the device is reset, means your node will be fenced if it loses quorum, if any monitor daemon is lost and not recovered. So whatever services you have configured, if something is some issue with that, it will do the fencing of that. And if pacemaker decides to fence the node, so in these scenarios your device will be fenced in diskless SBD also. And at the last we'll be discussing about SBD start mode options. So this controls whether your failed node will join back the cluster. So if let's say there is a issue in your one of the node in your cluster and pacemaker fenced it, so and the fence option you have said like it should be rebooted. So once it rebooted, will it join back the cluster or not join back? So that is decided via this SBD start mode option. So there are two options always. So whether any issue or not, the node will try to join back the cluster, or it will join back to the cluster whether there is an issue or not, irrespective of that. And clean is only when the cluster will allow it, when the node doesn't have any previous fencing history. So it is a clean, then only it will join back. So in that case, you have to do the previous step where I was showing you how you can clear the poison pill. You have to do that, then only it will be clean and it will join back to the cluster. And here you need to keep in mind, you need to always investigate previously fenced node before joining it back to the cluster, because you don't know whether there's any hardware issue or whether there's a configuration issue or whether there's an issue with the resource running on the node. So without checking that, and if you allow the node to join back the cluster, again it may get fenced or it may impact other nodes or running services on the cluster. It will instabilize your cluster. So that's why it's always suggested to investigate before joining back the node to the cluster. So thanks for your time to watch this video and understand the SBD and how the fencing can be done using SBD on Pacemaker. If you have liked our work and these tutorial videos, please press the like button in the YouTube page so that we can come to know that you liked it. You can use the comment section to let us know your thought on these videos so that we can take that as a suggestion and improve in our next videos. And at last, before going, I'll tell you, request you also, if you have not subscribed yet to my channel, Trich Tech Institute, please subscribe to it and also press the bell icon so that you get a notification whenever we upload any new video and you can watch that. Thank you. Thanks for your time. We'll see you in our next video.